might do still. Yeah. So today's talk is about WA Tsunami Coast. It's evidence of past tsunami events on the West Australian Indian Ocean coast. I'd just like to thank Susan Hopper for inviting me along today. We're at the Boya Community Centre in Western Australia, and it is Saturday, October 4th, 2025. Over the last few years, I've gone along about 700 kilometres of the Western Australian coast looking for tsunami evidence. Now, the main tsunami evidence is sand dunes, right? I've gone from Cape Leeuwin in the southwest to Dongara, 350 kilometres north of Perth. Okay. Now I'm going to introduce myself. So, I'm Simon Robinson. I'm from Liverpool in northwest England. That's Liverpool there. So this is the Wirral Peninsula, and this is a place called Parkgate. Now, I do have qualifications in geography and geology. I have A-levels. A-levels, for anyone who's not from the UK, they are pre-entry examinations for university. Right, so you have A-levels before you go to university, but I did not study geology at university. Okay, but I did study geology on many UK field trips. So, Wales, where we looked at rocks, yeah, and rivers. There was always someone who'd get the short straw and be the person who stands in the middle of the river with the flow meter. Right, yeah, you don't want to do that. Anyway, Merseyside, which is where I come from, this is Formby Beach, and we studied the sand dune formation in Ainsdale. So literally for my A-levels, I had to study sand dune formation, right, and Cumbria. This is Hardknott Pass. That there is England's steepest road, and this is a Roman fort. Yep, and that's me, and that's my executive producer. Right, and this is Crinkle Crags, and this here is a rock. Right, now when I was studying geography, did I get it in the eye? No, did I get you? No, okay. When I was studying geography and geology, whereas some people were interested in classifying different rocks and said, oh, that's got a slightly different crystal structure, which means it had this different origin from this, this, and this. It didn't interest me. I was not a rock collector. I didn't go around there looking for various rocks and like doing these things. What I did like to see, though, I was interested in things like plate tectonics. Where did the continents come from? How come there's a mountain range there? Where did that river start? Where does that river flow to? That was the thing that I was interested in. So on my field trips, when other people are looking at these little rocks, I'm looking at the mountains, yeah, and I'm looking at the rivers. You know, see this like, way the river meanders? That's the sort of thing that interested me. I do know about that rock, by the way. That's a rock that I collected, and I was really excited when I collected it. I'll tell you why later. So, this is about tsunamis. What is a tsunami? People have this idea about tsunamis that it's a wave that comes in. Oh, no, it's not. It's an absolute inundation. Look at that picture it's frightening, right? A tsunami is a change in the sea level that comes in as an immediate wave. Yeah, this is, as you can see, this is Miyagi Prefecture for the March 2011 tsunami. The earthquake was just off the coast of Miyagi Prefecture. In this town here, Miyako, it was right on the firing line for the tsunami. At this location, they built up 10-meter high tsunami barriers, and this tsunami came in at about 11 or 12 meters. Right? On top of that, well, so along the coast, it was about 8 or 9 meters, but in this region, it was about 12 meters, and they think there was an extra little added part because the earthquake also triggered an undersea landslide, which intensified the tsunami just at this location. And if you see as well, this town, Miyako, is in an inlet. right? So the 12-meter waves came in, overwhelmed 10-meter high seawall defences and carried on up the inlet. The other thing about tsunamis is it's a total flood. It keeps on coming, and it keeps on going, and it sloshes as well. Yeah, you know about bathwater. If the bathwater sloshes around and it goes up and down, the same thing happens with tsunamis. At Miyako, yeah, at Miyako, the run-up height, the highest point that the tsunami has reached inland was 40 meters above sea level. Yep, 40 meters is the height of an 8-story building. Right. I've never seen a tsunami. I never want to. Right. If there's a tsunami warning, heed it. Get to high ground. It's frightening. It's awful. Yep. Okay. What causes tsunamis? So the one that everybody knows about is earthquakes, especially on thrust faults. So the Japan 2011 tsunami and the 2004 December Indian Ocean tsunami, they are on thrust faults. So what's happened is there's two bits of the Earth's crust adjacent to each other, and they have a bit of a rupture, and one of them slides past the other vertically and horizontally. Vertically, not horizontally. So one goes up and one goes down, and that displaced a huge amount of water. So at the 2004 event, it was about 150 kilometers worth of Earth's crust moved by several meters. Yeah, I think it was about less than 10 meters, about 8. Now, I don't know whether it was feet or meters, but anyway, we know what happened in 2004 on December 26th, the most devastating tsunami in human history. Yeah, caused by an earthquake where one bit of ground moved up and down past the other. You also get landslides, volcanoes. The most famous one of them was Krakatoa. That's the volcano that that's the most studied volcano that's caused a tsunami because it inundated parts of Indonesia, and many people were killed by the tsunami as well as the volcano. Landslides into water. This happens occasionally in Alaska, of all places, and Alaska's got like a lot of fjords, and with global warming these days and things, a lot of the ground is becoming unstable, and regularly in the Alaskan fjords there is a landslide into water that causes tsunami just within the inlet itself. So whilst they are huge and the wave heights are bigger on these ones than in the open ocean, they're nothing on the same scale as like the 2004 Indian Ocean or the 2011 Japan tsunamis, even though the wave height goes higher. Undersea landslides. These can happen on any continental shelf anywhere on the planet. So you don't need to be near any sort of a plate boundary or volcanic area. More on that in a minute. And asteroids impacts maybe. The only asteroid impact that is definitely known to have caused a tsunami was the Chicxulub impact, which was the 65 or 66 million years ago impact that killed the dinosaurs. There's impact material all the way across North America, and definitely it's tsunami material. It's been very well identified from the KT boundary, or they've changed the name of the KT boundary to something else, but you know the place where I mean. Yep. Human activity, no, not even atomic blasts. The Americans have experimented in causing tsunamis. They did this in World War II and failed, and even the atomic blasts did not cause a tsunami. Okay. So we're on the WA coast. We are far from the usual tsunami sources. No earthquakes, volcanoes, or landslides into the water. But we do have undersea landslides on the edge of the continental slope and the Perth Canyon. There could well be a source of these sorts of tsunami events where it's an undersea landslide, maybe even triggered by like a small volcano where the sediment is built up over time, and that goes and sends a a landslide, undersea landslide, and then causes a tsunami. The thing about these types of tsunamis is they have like a dipole effect, and the immediately behind where this happens, it tends to get hit higher than other places. It still spreads out around. You can get undersea landslide tsunamis literally on any continental slope anywhere on the planet. So nowhere is immune to tsunamis. Okay, so little animation of a undersea landslide. Yep, it's exactly what it looks like. Okay. Now, the Dongara slides. Anyone heard of this? Not heard of the Dongara slides? Okay. Off the coast of Norway, 7,800 to 8,200 years BP, which is before present for anyone who doesn't know.
I thought it was BCE, before Common Era.
Before present, and then we know what it means. Yeah. So what happened with the Dongara slides? This was towards the end of the last ice age. So the ice age had created huge amounts of sediments that had been washing into and along the continental shelf off the coast of Norway, compounded by ice age sea level changes, because as the sea levels go up and down, the pressure on the rocks on the continental slope is going to change, and it might just cause an instability that sets off the slide. It could also be like a small earthquake that sets this off, okay? But it's important to know you don't need earthquakes specifically, you don't need volcanoes, and these things can occur even in a seismically stable place such as Norway. So it left evidence around the North Atlantic, including the UK. So you probably work out what this is. This is from Hoyk in northeast England, not even in Scotland, in England, tsunami deposits. So this is from the YouTube video, The Impact of the Dongara Slide Tsunami on the Mesolithic Population of Britain. And what you've got to look at here is the boulders that are within this core. So this core was taken from near an estuary where lots of river sediment, and there was river sediment, then there was a boulder core, and there was more sediment on top. And it could be very easily dated, and it came out to a couple of different events, 7,800 to 8,200 years ago. So credit here, the Society of Antiquaries of Scotland and Clive Waddington, who's on the video, okay? So this is how we look for tsunamis. This is the evidence. We look for boulders in the wrong place. Yep. If there's boulders in the wrong place, you go, how did they get there? Yep. Coarse sand layers. Yep. This sand layer here that they're pointing out was directly from the Indian Ocean 2004 event. So this is Banda Aceh, and this is a cave right at the tip of Banda Aceh. Banda Aceh was the place that took the was at the forefront of the 2004 Indian Ocean tsunami. So credit here is the Earth Observatory of Singapore. Patrick Daly was the researcher, again, YouTube video. Important things to note here. You can see the sand layer, you can see it there, you can see it's different from all the other things, and it's out of place compared to the other deposits above and below. They dug down in this cave, and they found tsunami layer after tsunami layer after tsunami layer, which means that the 2004 Indian Ocean event has reoccurred every several hundred years, going back as far as the sediments were. Yeah. If there is a tsunami in one place, they likely reoccur. So one of the things we look at in Western Australia is the Perth Canyon. As Susan will tell you, the Perth Canyon is a possible source of tsunamis to like WA. Right? Don't panic if you are here right now. If there's a tsunami going on right this second, we are safe. Right, but obviously not where I live. Okay, so boulders, coarse sand layers, ghost forests. Has anyone ever seen ghost forests before?
I've heard about them.
You've heard about them?
I've seen a program that's actually on, yeah.
Oh,
I've
yeah.
seen that.
Yep, okay.
Yeah.
So,
So it might be this one.
yeah, it probably is, because this is the most famous one. Okay, so this is in Washington State, USA. Credited is Nick Zentner, and this is the Central Washington University. And he also has a YouTube channel which is called Nick on the Rocks, so he does geology programs. You can see what this means, ghost forest. You can see the trees, they're dead, but they're actually they've died in situ. So when the tsunami wave came in, it obviously comes with a load of salt water. The salt water kills the trees, but also preserves them in situ. Yep. They were able to carbon date these things, plus there's the same sort of layers of sediment and stuff. And these layers go back, it's every 300 years like clockwork, right? The Cascadia Fault. So the Cascadia Fault is just off the coast of USA and Canada, and it's another one of these up and down thrust faults. These happen every 300 years. You're checking your watch. Yep. Yeah, check your watch for this one, right? Because, yeah, right. This one here that caused that one happened on January 26th, 1700, at about 9 p.m. Pacific time. I know this, right? This particular event, the 1700 event. Oh, remember I just said they happen every 300 years. We're 25 years overdue.
Yeah.
Oh,
Right?
it's late.
Yep.
You might carry trouble away.
Could we vote for that right now, please? All those who say aye. So this tsunami actually is also famous because it didn't just affect the coast of Cascadia region of the USA and Canada. It spread right across the Pacific Ocean. And there was a small fishing village in Japan where the fishermen were out doing their fishing. And when they came back to their village, the village had been obliterated by a tsunami.
Oh, goodness.
Yeah.
Just was like a gentle swell where they.
Yeah, if you are in the open ocean and a tsunami goes past, yeah, happy days.
Don't see it.
You don't feel it, because a tsunami wave can be like hundreds of kilometers wide. So your boat goes up by a few centimeters. Yeah, stays up for a few centimeters, goes back down again.
I guess where it rises is when it
Yeah,
goes into shallow.
like the waves at Costello Beach, right? In the open ocean, they're no problem, but when they hit the beach, that's when they turn into breakers. So as it comes into land, let me throw my thingies down. So here's the land, here's the tsunami coming in. The tsunami wave slows down, right, because it's hitting land. It slows down, it goes up, yeah. It compresses, and all of a sudden you've got an inundation onto the land, yeah. So, but because it's such a long wave, it's not a breaking wave. It's an inundation flood. For the time when this tsunami is going on, the sea level is higher. And if you are standing on a piece of ground that was above sea level, but is now below the current sea level, you are in trouble. Right? If you're ever in Bali and the alarm goes off, follow the instructions. Yeah? Oh, anyway, the fishermen in Japan got back to their village. They didn't know that the tsunami had gone past. And they said, well, what is this? They said, well, it must have been a wave just within the harbour. They called it a harbour wave. Anyone know the name of harbour wave? Tsunami. And it was the 1700 event that happened on the 26th of January at about 9 p.m. And we know this because the Japanese historians recorded this. So that's why we can pinpoint this one so precisely. So it's not me who's got this information, it's the researchers who went through the records in Japan. After seeing this information in Washington State, the ghost forests and the sand layers and things like that, they went back through the Japanese records and they found these Cascadia faults every 300 years. Yeah. And like I say, check your watch because it's late. So, what's the first recording of a tsunami in Australia? Difficult to say, but if we're talking about the geomythology of the Noongar people, there is a story. This is the first time you ever heard this story, I hope. And that nobody actually read this one word for word like about an hour ago. Right. So this is by George Fletcher Moore, who was one of the British colonists who came around in the, he was around like the 1820s and stuff, and he travelled all the way around WA with the express intent of speaking to Noongar people and learning about them and writing down their language. He was the first person who wrote down the word quokka. So a quokka, but he wrote it down with a K, right? So I'll read it because you need to hear it. Rottnest, Carnac and Garden Island once formed part of the mainland, and that the intervening ground was thickly covered with trees, which took fire in some unaccountable way and burned with such intensity that the ground split asunder with a great noise and the sea rushed in between, cutting off those islands from the mainland. It sounds like a tsunami to me. Yeah. I'll dismiss the fire part because how many bushfires do we have in WA? How many times does the bushfire go through and devastate an entire region, and then you'll forget about it for 10 years, and then the fire comes through again 10 years' time? But this sounds like a tsunami. But very definitely, this story from the Noongar people exactly matches what we have with the geological record. Very definitely, Rottnest Island was connected to the mainland about 6,000 years ago. And this story of Rottnest being cut off obviously stayed within the collective stories and memories of the Noongar people. So it might just be talking about sea level rise. It might be that there was as this came in, there was like a rapid sea level rise, but it could be a tsunami as well. So it's one interpretation, but that's the first. There are a few other tsunami stories, but they're not as clear as this one. This is the very clearest story I was able to come across from the Aboriginal peoples. This is the closest match. So, yep, 12:30. Excuse me, I've got to change the memory cards. Okay. The evidence, other people have seen evidence of displaced boulders along the WA coastline. I have not seen any boulders. There was one boulder which is called Merchant Rock at, it's on Borenup Ridge. This is Conto's Beach in the Margaret River region. But have a look at well, let's watch the video. So this is the rock. So I made a 3D model of this one, just to examine it and see. But the idea was that this rock was nudged by a tsunami and cracked in half. But I just think that the rock has been undermined over time. And because it's just a heavy rock, it's just cracked open. This to me is not tsunami evidence. Some people say it is, but I don't think so. But there you go. You've got a model of the rock. Oh, I forgot to take my banana, so I had to put myself in the picture.
That was huge.
You should have seen the size. Yeah, it is I put myself in there because when I got there, I thought I was going to be seeing something that was half the size of that. When I looked at it, it's like, wow. Yeah. I don't think that was done by a tsunami. I don't care how big the tsunami is. It can't do that, in my opinion. Okay. Now, For the rest of the presentation, these are the places where we are going to be travelling to. Leeuwin Ridge, so I've looked, Leeuwin Ridge is the place that I've investigated more than anywhere else, followed by Bunbury. On Leeuwin Ridge, there are multiple chevrons that are interpreted as tsunami evidence. Have you heard of tsunami chevrons? Do you know what we're looking at for and looking about? Okay, so these things are up to, some of them can be like, 500 meters, 700 meters long, and it's two parallel ridges of sand that come to a point. Yeah, and this ties in with some other evidence as well around the place. And the idea is, as the tsunami comes in, it drags with it a load of sand and washes the sand up as it's going. Just for local geographical reasons, it just happens to pile up in this region, and it carries the sand along, forms these ridges, and then as the backwash goes back out, it scours through the middle because it's slightly lower. And that's the theory about the formation of tsunami chevrons. So I've looked at this and gone, okay, let me investigate whether these are actually tsunami chevrons. Let me see if this is evidence of tsunamis. So I have looked at tsunami chevrons along a 700-kilometre stretch of the WA coast. Well, let's go. Okay, now, right. I'm going to take you back a step though. Like I said before, for my A levels, we had to literally study sand dune formation. You measure along, they call it a transect from the water's edge, from the low water mark or the high water mark to the climatic climax vegetation type. And you watch and you study and so you understand how all of the different features from the water all the way up to full forest are actually formed. So I've studied this. Right? So you need a few things to make sand dunes. First off, right, you need abundant sand. You need drying sand. You need a large tidal range. This is really important. So around here, we've got no tide whatsoever. It goes up and down by about this much, I don't know. Yeah. Where I come from in Liverpool, which is now behind the thing, the tidal range in Liverpool is 9 meters. Every single day, the tide comes in and out by 9 meters. Yep. You need low-lying land, because the sand needs to be able to blow along the beach and then sort of gather up behind the beach. The winds must be strong enough to transport sand grains, and only the fine particles can be transported via surface creep, saltation, and suspension. Surface creep, it rolls along. Suspension, it's suspended in the air and blows along. Does anyone know what saltation is? I forgot to bring my Jenga. I was going to do a saltation demonstration with Jenga. Right, Johnny, get a close up. Right, and I'll fill it in later. Right. So what happens with saltation? It's a bit like playing snooker. Right. When you are popping the red ball, you can't just touch the red ball. You've got to touch the cue ball, the white ball, with your cue. You hit the cue against the white ball hits the red ball, well, it misses the pocket when I do it, but you know what I mean. With saltation, what happens is the wind comes along, it gives one of the sand particles a little bit of kinetic energy, gives a hop. That goes up and hops and lands again, and that hop, the kinetic energy from the hop is then transferred to the next sand particle along, and that jumps. And then it hits another one, and that jumps. And then the next one jumps, the next one jumps. That's saltation. Now, has anybody ever been to like Cottesloe Beach and stuff on an extremely windy day? I have, in my research, right? I sat there for an hour in 35-kilometre winds, watching sand move. I did. You've seen the video? Yes, Susan will confirm. If you stand up, you're fine. If you crouch down, you get sand blasted in your face. Yeah, because the suspension is like lower than there. So if you look along and you see sand dunes on the top of a cliff, like Okay, let's, what are we going to see next? Okay. Right, Aeolian dunes. During this research, I often only have like a short time. I had an hour to go to Formby. And it was blowing a gale. So my plan of flying the drone all the way over lots of dunes sort of, died a little bit. But let me show you this. It's compare and contrast. So this is Formby, just a few miles from Liverpool. These are wind-blown dunes. The tide is in, by the way, on this one. Yeah, and these blow across. So this is close to the place where we studied the transect of sand dunes. But these are sort of separated dunes. Yeah. I couldn't go any further because of the wind this day. It was like 40-kilometre winds, and the drone is not rated for 40 kilometres. Right. Oh, this is Rhyl in North Wales. That's a UK beach. Can you see the difference between a UK beach and an Western Australian beach? The width of the sand. You need that width of sand because remember how high the tides are. The tide goes out, the sand dries out through the day, the wind picks up, and now the sand can blow along. If the sea doesn't retreat and expose the sand, which dries out, the sand can't blow along. So it can't blow out of the ocean. So if you find sand, you're thinking, where does it come from? Oh, does anybody know where sand actually comes from, by the way?
From the sand factory.
It comes from the sand factory. You are correct. Yeah. Anyone give me a shout. Where does sand come from?
Decomposed granite.
I like your answer. Yep. Here's my granite sample. Nice. Okay, let me show you where sand comes from, because the obvious answer is like, where does it come from? Well, it comes from the sea. It does, but it doesn't start in the sea. So this is where sand starts, places like this. This is there's a hard knot pass just next to that Roman fort. Starts out, it will weather out of the rock. It will then start to be eroded by these little streams and rivers. These smaller streams turn into bigger streams, yeah, which turn into bigger rivers, which flow to the sea, where they deposit their sand. This is a sand flat in Parkgate in the Wirral, and that's the River Dee flowing out into the Irish Sea. Now, let me just go back to that one there, about there. Just to let you know how much sand is being deposited around the northwest of England and North Wales, because that's Wales on the right. That there is the seawall that was built in the 1850s. It's now 1.5 kilometres away from the sea. From 1850 to 2025. I mean, even within my lifetime, the map of this area has had to be redrawn and give it more land. If we go back up the River Dee in that direction, so somewhere up there, is the city of Chester. In Roman times, the city of Chester was one of the main Roman forts bringing stuff in and out of Britain. That's now landlocked inland by about 15 kilometres. So in 2,000 years, this river is no longer navigable. No. So in WA, we have nothing like this. There's one other thing as well, glaciation. Yeah. In the UK and Europe, for a time, it was covered by glaciers, like 24,000 years ago was the depth of the last ice age. So what the glaciers did, they scoured out huge parts of the land. This is Wastwater, and if you see, this is a U-shaped valley. This is England's deepest lake, and behind it in the mist is England's highest mountain, which is Scafell Pike. This is December, the height of summer, by the way. Does it look bleak? Does it look bleak? Okay. Okay. Here's me talking about how the glacier came along and came through and dragged the stones along. Yeah. Okay. I'm going to pause this one here. He says, pause, pause, pause. Okay, pause. Excellent. Pause at exactly the right spot. So this is Cumbria, right? That's the Lake District. That was the source of a lot of the ice around this area. If you look, these are all lakes that radiate out from the centre. The centre of Cumbria is like the central mass of Cumbria, quite high mountains where the glacier formed, and it flowed outwards, right? Now, you see, somewhere just about there is a town called Shap. Has anybody heard of the town of Shap? Has anybody ever driven on the M6 between England and Scotland? You haven't? Oh, you've not lived? Yeah. So you know how bleak it looked when I'm standing next to the lake, right? It's the bleakest motorway anywhere that you will ever go. It is dull, it is grey. Right, anyways, but that's the town of Shap. Now, if we go forwards on this video, this is Thurston Cliffs, yeah, and this is still the middle of summer, but look at me with my coat on. This here is a glacial deposit of boulder clay that's full of rocks. So earlier on, when I said, okay, that's a rock, that's where I picked it up from. It's 136 kilometers away from the source. Yeah, the glacier pulled it that far. Now, it's better still because only about 10% of the rocks on this beach are actually granite. And about 99% of the rocks on this beach are Scottish granite. So the glaciers from Scotland came down, joined with the glaciers from Cumbria, and they got to here and they dropped off all the rocks. So I was walking along and went, oh, look at that, a piece of granite, picked it up. And it was like about a 1 in 1,000 chance. Right? That rock that I had before is a piece of granite from Shap. Right? Really easily identifiable because of it's quite pink with large feldspar crystals. So whilst I'm not interested in classifying them, when I get one that's as obvious as that, and it does have to like smack me in the face before I understand what it is, right? A piece of Shap granite. I was like excited. That's now in my daughter-in-law's rock collection. Yeah. So, but there you go. What this does, though, the glaciation, it scours the land, drags out all of the sand, and dumps it in the sea. Yeah. So, obviously, in WA, we didn't have glaciers. The last time there was possible glaciation in Western Australia was maybe 30 to 45 million years ago, when the continent was far further south and still partly connected to Antarctica, I think, or it might have split from Antarctica by then, but no glaciers since. So, in fact, yeah, let me show you how much sediment there are in the rivers of WA. Look at that, look how crystal clear that is. No sediment in it whatsoever. What this means is that, first off, we've got no mountains in WA, we've got no rainfall, and the rivers hardly even flow. So there's no new sands that's being deposited from land into sea. It's not a sand deposition area. Moor River at Gilderton. I mean, half the rivers in WA are so lacking in flow, I was going to use other words then, they don't even reach the sea. And that's a typical width of a WA beach, by the way, about this far. Yeah? It's not a sand-producing area. What sand is here just it doesn't get dry enough to blow onto the land. And yes, we find sand dunes in unusual places. Like, so here we are, Leeuwin Ridge, yeah, Cape Leeuwin up to Hamlin Bay, and that's a sand dune. Yeah, that's due west. This is due east. So that direction on that one is east. That's a sand dune. Keep going. The sand dunes actually go up to 220 meters above sea level. You can see the change in vegetation type. This side is coastal heath. This side here is mature karri forest. These trees are growing in mature soil. These trees here are growing on a sand layer. These trees here are about 3 meters high, and they're 40 meters high. And the sand layer goes down, and you can't see it unless you stand on the ground and look at the thing. But you get, let me just pause that thingy while I'm having a rant. So, small trees, but when you stand there, the big trees are on a lower level. The smaller trees are on a higher level. So they look quite similar in height, but they're not, because the big trees are grown in soil. That sort of soil, yep. And the small trees are growing on sand, that sort of sand, up there. Yep. And again, you've got these chevron ridges. So, I mean, I know there were stories about something called the late Holocene high stand. Okay, so these are sand dunes, and this is Tomala limestone. So I took that picture, and then I took this picture from that side. Sand dunes, Tomala limestone, tiny little beach. Close up of the Tomala limestone to show the rhyoliths and the cross-banding. And that there, let me pause this, oh, go back one. I forgot to put my Swiss Army knife down to take this picture. That there is a coarse sand layer. And remember, the wind can only blow the finest of particles. And if you stand up on a windy day at the beach, you don't get it in your face. How did this is coarse sand. The only way the sand can get there is if it was washed in by a wave. Either the sea level was at some point more than 30 meters higher than what it is right now, which I don't think it was, yeah, or it got there some other way. Yep. And next up, we're at Margaret River Sculpture Park, and I'll direct you. So there's the edge of the sand layer just there. It cuts across the property of the Margaret River Sculpture Park. That's the sand pit. This is Brendan Booth, who's a local artist and craftsman. He makes handmade furniture, and he owns the land. And he's dug down this sand pit, and he scraped out this. That's from 1 meter below. That's not wind-blown sand. That's washed in by water. Coarse sand. This is 30 meters above sea level, 3.4 kilometers from where the sea is right now. So that was Leeuwin Ridge. Bunbury. Bunbury is my favourite place. It really is. Some say that the last exciting thing that happened in Bunbury is when the volcanic rock was formed, but yeah, maybe. But so this is the Leishno Peninsula. But we start off a little bit south. Do you know there's no sand dunes around Busselton? And the very first sand dune, that's Busselton that way. Apart from these little 4 dunes, that's the very first sand dune that's found north of the Cape to Cape region on the Perth coastal plain. Right? And that's the start of the chevron dunes, and they sort of get bigger and bigger down this way. Yeah. And there you go. There's a chevron. So that's facing due east. Yep. Now this one, I made a 3D model of some of this one because I was looking. I made a 3D model of this chevron here that goes there and there, and right in the middle of this chevron is this feature here. That's a blowout. Yeah. So that's the direction of the chevron, and the wind direction is going that way. So the chevron was there first, and the blowout has cut across it. So the chevron points due east, and yet the prevailing wind is that way. Yeah? So the direction of the chevrons does not match the prevailing wind. We can go on, go on, go on, go on. This is at Daliellup. Now we're at the Leishno Peninsula, and again, we've got these longitudinal things. Okay, here's some boulders. I remembered now to put my Swiss Army knife down. Different boulders, like a greyish one, coarse ones, and these are up to 30 centimetres across. Now, the outcrop where these are, oh, hold on. I'll just stop that one a moment. The outcrop where these boulders are is a couple of metres below where they are now. Now, you can try this yourself on the windiest day. Get a rock and drop it and see if it flies sideways. I've literally done it on camera just to prove that they don't. And yet, these rocks are found above where the rock outcrop is. The answer is, what are we looking for? We're looking for coarse sand. Yeah, we're looking for boulders in places where they shouldn't be. What was the third thing we were looking for?
Chevron.
Ghost forests.
Oh, yes.
Ghost forests. So I'm going over on time. Here we go, Leschenault Peninsula. There's a ghost forest. These trees were killed by a rapid inundation of salt water. The salt water has now preserved them. And this is in Leschenault Peninsula. I'd love to carbon date these, and I've got people who will do, provided I can go and pull the tree out. There you go, ghost forests. We've got ghost forests, we've got boulders out of place, we've got sand layers, coarse sand layers is the important thing, unsorted coarse sand layers where they shouldn't be. So let's now move north of Perth, and we're at Dongara, and this is a limesand dune. It's called limesand dunes. How long ago would it have happened? The tsunami. Yeah. Someone has looked at some displaced boulders that are out of where they should be, higher up so they're not at sea level, they're a few metres above, and pulled barnacles from them that were carbon dated to 5,000 years ago. Yep. That's not my evidence, that's what somebody else has said. Yep. I'll go along with that. Yep. So, sand dunes in... So these are like the dunes in Lancelin. Has anyone been four-wheel driving in Lancelin? Yeah. Yep. Is the sand coarse or smooth? Like, fine? Fine. Fine. Okay. So have a look at this. We've got some chevron remnants, and then this is usually vegetated. The bushfire had gone through here in the last few years. And this sand that's just lying around in the ground is now exposed. And sometimes we get huge dune fields of limesand that spend their time migrating across the landscape. But look at this part here. At the edge of the sand dune, the vegetation starts to take root again. So I think it's pretty obvious which direction that's going. But look at this line there and that line there, where the vegetation is taking root. Yeah. And look at those features there. That's a chevron with a limesand dune next to it. And the edge of the lime dune is doing this. Okay. We now go further north. Arrowsmith. Does anybody know where Arrowsmith is?
No.
Have people not heard of Arrowsmith? It's a big county north of Perth. The population is 0. Right. So this is south of Dongara. Yeah, this is south of Dongara. And what we've got here are some chevrons. And so this bit here is Arrowsmith. This bit here is called Carson's Beach, and Dongara is just there. And this dune here was the one this chevron was the one that was coming to video. I made a video a few years ago where I said that it looks like the tsunami came along the coast here and made landfall again here. Because of just the shape of the land, it was heading in that direction, and it bypassed Arrowsmith and instead hit at Carson's Beach. And it took me 2 years to get to this spot. Of 2 years of planning to get to this spot. But right, this is Arrowsmith. There's no dunes in Arrowsmith. It's clear of dunes for some reason. It's just like there's no big sand dunes there. Oh, so it gets here, right? Now let me just talk you through this bit here. Right. due to time constraints, getting to and from this spot here, I could only get there at around about 12 noon. At which point the temperature is now about 43 degrees. Right. Now my Sony camera and Sigma lens is only rated to 40 degrees centigrade, and it's 43, and I didn't have an umbrella over the thing, and the camera failed. I've been planning this for 2 years. It was a 2-day trip. This was a okay. Yep. The camera failed, but I got the drone up. This is what I came for. This shot. That chevron there was what it came all this way. Literally years of planning, right? Oh, and you'll notice here, there's no cars going along the road. There was only us, right? And there's the chevrons. In fact, I'm going to make this one. This might crash everything, but full screen, because you've got to see this. This is amazing. The evidence what I pulled from here is absolutely astounding. And I say that in full knowledge of what's coming next. Right. There's the chevrons. See them? Very clearly. Little 4 dunes there, and then there. Okay. Yeah. It's the most bleak, awful place, and I never want to go back there. It's awful. It was horrendous. It was nasty. It was just so difficult. Still no cars. Well, look at those dunes. But also, see these here? There's more of these lime sand dunes. Right. Now, okay, let me pause again on this one, because we're about to get to the punchline. Right. I got my drone out, set it up, and it said, error, will not fly. I took it back inside the car and left it in the air conditioning. Right. Took it back outside, error, will not fly. I got my backup drone up, which is like 5 years older, and it flew. It goes up and it starts saying overheating error, overheating error, overheating error. I had an hour's worth of battery at this location. 2 years in the planning. 2 years in the planning. Literally 1,000 kilometers worth of driving to get to this spot. Yeah. And watch the, I got about, in the end, where are we? There we are, there we are, there we are, there we are. I got about, in the end, about 5 minutes footage. Right. But look at those dunes. Look at them. Look at that chevron. Look at the point of the chevron. Look at it. Yeah, look at that chevron. Have you ever seen better evidence of a tsunami in all your life? And keep watching this one. Okay, there we go. Look at them. I actually got the shot. I'm flying over the chevron dunes. Yeah, look at it. 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 And then the drone error, drone error, drone error, drone error. Watch it go. Watch it go. Watch it go. Watch it go. Watch the horizon. You'll spot it. Oh, there it goes. The drone is now in failure mode. It's like, and the SD card is in the drone.
Did it get back to you?
At this point, I thought, uh-oh, let's bring it back. Yeah, because, I mean, I don't want to lose the drone. Okay, but the efforts for getting to this spot to do this one was just, it was horrendous. Okay. Yeah, you'd think so, wouldn't you? You'd think that somebody's had the intelligence to work this out.
Yes.
Yeah.
You need to go further north in the summer.
Oh, you've killed it, you stupid machine. I'm aware that I'm going over time, by the way, and I'm aware I'm eating into, but we're near the punchline. I'm about to get to the punchline. Okay, I've spent the gym fields. Okay, right. No, that's the same one. Okay, we're on the same one. Let's go. That one. The dunes. Okay, tsunami chevrons, yes or no?
Yes.
Yes. Oh dear. Oh dear. I've been chasing these tsunami chevrons from the tip of Cape Leeuwin up to this spot here, trying to find evidence to confirm that these are tsunami chevrons, because other people in the past said these are not caused by tsunamis, these are wind-blown features. And I said, I will show you that these are definitely tsunami features. Anyway, here we go. This is the punchline. Okay, let's zoom in on this one. This is, what's this one? White point it's called. Can anybody identify this geographical feature?
Sand dune.
Sand dune, it's got a particular name. This has got an Arabic name because these are found in places like the Arabian desert. You'll find them in the Sahara Desert. These are found only in places where it's an arid desert where there is loose sand that can blow about.
Yeah.
As far as I know, these are the only Barkhan dunes in WA. That there.
What's it called?
A Barkhan dune. Spelled Barchan. Barkhan. Yeah? And do you know what? These blow along and the edges get a little bit caught up with vegetation. And it continues to blow and blow forwards. And the edges get a little bit more vegetation. And eventually it runs out of energy and leaves a chevron behind it. The chevron dunes
Channel.
that I've been chasing from Leeuwin up to Dongara, they are not tsunami evidence. I've proven that they're not. All those ridges on Leeuwin Ridge, north and south of Bunbury, Mandurah, yeah, it's not tsunami evidence.
Yay!
Oh, thank you. You know how much money I've put into this. Yeah.
The next one was, but
Yeah. Oh God, no. Hold on, please. You've jumped the gun. Right. Let me go to the next slide. But this is the base of all of these dunes. You tell me what that looks like. Is that wind-blown sand?
No.
So this comes from migration of limesand dunes in WA. This is from an official government document. They've remembered the Swiss Army knife. Look at the size of those things. This is some kilometres from the current seafront and several metres above sea. The chevrons are the thing that are not tsunami evidence, but the coarse sand, it is. So what have we got left in WA? We've got coarse sand, we've got boulders where they shouldn't be, we've got ghost forests, and we've got this Tamala limestone with these bits and pieces. That's for another presentation. But we've lost the chevrons, but we've still got coarse sand, boulders, and ghost forest. So, as an amateur researcher, yeah, I prefer the term gentleman, but Sue reckons I'm an amateur. Right. I just can't do the next stage of this. So it needs core sampling in multiple locations, GPR surveys, ground penetration rate, foraminifera surveys. Foraminifera are like microorganisms that are only in water. They never blow out. They can only be washed in. So if you find foraminifera in your deposit, you've got a marine deposit. And data evidence from the Leschenault ghost forest. If anybody can help with this, any university friends, researchers, anything like that whatsoever, you know how to get hold of me, right? Okay. Now, geomorphology lessons. Can we learn anything from the information that's passed on from older generations to younger generations in an oral tradition? Can we learn from it today? Right. Now, this might not actually be talking about a tsunami, but it definitely is talking about sea level rise. So the Noongar people knew about sea level rise. They might not have connected all the dots and said this is due to rising sea levels, due to we're coming out at the end of an ice age. No, but they knew it happened. we've got sea level rise right now in 2025, and it could get really bad. Future generations. Yeah, I worry about my grandkids. I mean, yeah, like I say, we are fine here, but I live in Netherlands, we're 200 metres away from the river.
We could be down at the bottom of Green Mountain Hill with a long pole.
Yeah. Yeah. I mean, in a
Important bloody land.
worst case scenario, let me give you the worst case scenario. Quokkas are evicted from Rottnest Island, and they are relocated to the newly named Kings Park Island. Yeah, think that through. Yeah. So, right, tsunamis, that was something that were forgotten by Western civilization, by us. Sea level rise was forgotten by people like us. But there's a couple of anecdotes. In the 2004 Indian Ocean tsunami event, the people of Banda Aceh, who have been hit by tsunami after tsunami after tsunami, had no idea that the tsunami was coming when there was the earthquake, when the ground shook. But the Andaman Islanders and the North Senegalese Islanders felt the shaking, and their tradition says when the ground shakes, go to the hills because a big wave is coming.
Oh, wow.
And they survived.
Yeah.
Yeah. Okay.
Need to remember the history.
In Thailand, in 2004, the sea retreated out, and a load of the tourists walked right out onto the seabed. That didn't end well.
No.
On one of the beaches, have you heard this one? There was a 10-year-old girl who'd done a science lesson. And they'd been talking about tsunamis, and she alerted everybody on the beach. And you've heard this one, yeah. Because she'd been to a science lesson, she knew about tsunamis, and about 100 people were saved from the wave. So, what is more important than teaching history to children?
Teaching science.
I'll go with that one. Thank you.
We actually knew there was a water level change at Rottnest. We were at Rottnest
Yeah.
when 2004.
Yeah, yeah.
And we saw the